In this question we're dealing with an aircraft of wingspan 42 meters, which is moving 1,000 kilometers in a second. That is 1,000 times 10 to the 3 meters divided by 3,600 seconds, meters per second. Okay, so that, when you do the calculation, is 277.8 meters per second. So in 1 second it cuts through this area here, okay, which is 42 times 277.8, which gives us an area of 11,676 meters squared. The flux cut per second of the aircraft, then, phi is equal to B times A. So B, 4.5 times 10 to the minus 5 Teslas, times an area of 11,676 meters squared, gives us a flux density, a flux cut of 0.53 Webers. The part 2, which is the magnitude of the potential difference between the wingtips, we need to use Faraday's law for this, and Faraday's law states that the induced EMF is equal to the rate of change of flux linkage. In other words, the flux linkage cut per second. We've just calculated that as 0.53 Webers, so the EMF induced is 0.53 volts. In part 3, if the aircraft flew due west, it would be cutting across the magnetic field in the opposite direction. So the EMF would have the same value, but it would have the opposite sign. In question 38, obviously where there's no conductor to fall through in P, no EMF is induced. But in R also, because the conductor is an incomplete circuit, no current can flow, so no EMF can be induced, and especially no back EMF to oppose the fall. So Q falls, and because of Lenz's law, the induced EMF in the loop opposes the motion, so that its acceleration is less as it's falling through it. So P and R arrive together and Q arrives after them, which means that the answer is A.